Hello, everyone, and welcome to the very last week of math this year. Can't believe that we are already heading into 2021. We've learned so much, so let's finish the week off strong. This week, we are going to be generating and analyzing number patterns and identifying prime and composite numbers. So a prime number is a number that has just two factors, the number 1 and that number itself. For example, the number 2, 3, 5, 7, and 11 are all examples of prime numbers because only one and each of those numbers multiplied together gives us that number. Composite numbers are numbers that have more than two factors. So here are some examples of numbers that have more than two factors. If we take the number 6, for example, we have 1 is a factor of 6, 6 is a factor of 6, the number 2 and the number 3 are also factors of 6. So all of these numbers have more than two factors. Very important to note is that 0 and 1 are neither prime nor composite. They are just kind of in their own category. So this I showed you last week, and it's super useful to use in order to come up with factors for numbers, right? We looked at this last week, but again, this knowledge and these skills are going to be so critical as we move this week. Now, let's look at some examples of prime and composite numbers. Let's actually try them out for ourselves, keeping in mind everything that we know and everything that we've learned over the past couple of weeks, right? So if a number is even, that means that 2 will definitely be a factor of that number. If a number ends in 0 or 5, for example, that means that 5 will definitely be a factor of that number and therefore will be composite. Okay, if a number ends in 0, that means that 10 will be a factor of that number. And then there are some other tips and tricks in here. Those are a tidbit more complicated, but still they're useful. So with 3, for example, if a number, or rather if 3 and 2 are factors of that number, then it definitely means that 6, for example, is a factor of the number as well. And then with 3, if the sum of the digits in that number, right? Like, so if I had 15, for example, right? Just by looking at this, I know that 3 is a factor of 15 because, right, when I add 1 and 5, I get 6, and 6 is a multiple of 3. So there are some other tricks there to kind of keep in mind and to remember. Now let's look at this little exercise fun game that's here. There's a list of numbers below kind of spread out. We are going to group these numbers into the correct bucket. So which numbers are prime? Remember, prime means that the number has just two factors, that number and the number 1, and then composite numbers, meaning that the number has more than two factors. So starting off with 65, just by looking at this, I know that 65 is composite because it ends in 5, right? So if a number ends with 5, that means that 5 is definitely a factor of that number. So 5 times, I think it's 13. Yes, it is 13 because I know that 5 times 12 is 60. So let's add 5 to that. That gives us 13. So 65 is definitely composite. Oops, it isn't allowing me to do this. So let's just go back a second here. Okay, and then we're gonna type these in or enter these in. So here we have 65 is definitely composite. So we're done with 65 here. Now let's look at the number 81, for example. Right off the bat, I know that 9 times 9 is 81. So that tells me there's 9 as a factor. There's 1, there's 81. That's already 3 factors, more than 2. So we're going to put 81 in this bucket, in this category. So 81 is composite. 23. Can't think of a number other than 1 and 23. So 23 is an example of a prime number. The number 23 has two factors, 1 and 23. And 70, it ends in 0, right? So this tells us that 10 is definitely a factor, right? 10, 7, 1, 70, and then 2, right? Of course, yes, 2, it's even. So 2 and 35. And there could be some other factors out there, right? So there's definitely more than 2 already. So we're going to put 70 in this bucket. And let's keep going. 49, that's knowing your basic multiplication facts. So 7 times 7 is 49. So that's already 7, 1, and 49. That's more than 3. So this is composite. So let's go 49 here. 58, there's going to be 1. There will be 58. There will be 2. And something else, whatever that is. So that's already more than 2. So 58. I think it's 29. I think it's 2 and 29. It took me a second to think about that. Hopefully I'm correct. If not, then you can correct me next time around. 58, and then we have 11. So 11 goes here because only 1 times 11 gives us 11. Let's keep going. 16. 16 is, if you guess composite, you're absolutely correct because there's 1 times 16. There's 2 times 8. And there's 4. Whoops, 4. Let me make this 4 look a little neater. 4 times 4. So here we already have 5 different factors. So 16 goes here. 37, I believe, goes here. Prime, there's only 1 in 37. 100, that's a pretty large number, but it doesn't, just because the number is like 3 digits long or large, it doesn't necessarily mean that it's composite. But in this case, we know that it is composite. There's 1 times 100. There's 2 times 50. There's 4 times 25, etc., etc. So here's 100. And then we have 93. 93 is composite. Most people may not know that kind of right off the top of their head, but kind of keeping those little tips and tricks in mind. If you know, right, with the 3 trick, it's right, if you add up the digits that make up the number, in this case, we would get 12. 12 is a multiple of the number 3. So this means that 3 is definitely one of the factors. 3 times something. I don't know what that something is right off the top of my head, but 3 times some number, and then 1 times 93, of course, will give us 93. So 93 is definitely composite. If you find out that it isn't, please let me know because I make mistakes sometimes, but I'm pretty sure that I'm right on this one. And then finally, 30 is composite, right? There's 1 times 30, there's 2 times 15, 3 times 10, 5 times 6. So that's already more than 2 factors. So let's just have a quick look at the numbers that we ended up with in each category. We have about 3 numbers in the prime bucket. And then we have, it looks like we have 9 in the composite bucket. So this goes to show us that if we're thinking about numbers from 1 to 100, most are going to be composite. Let's move on. And this here is what we call a prime numbers chart. I mean, there are so many numbers here. There are 100 numbers here. It isn't necessary to kind of memorize them. Like we ask our students to really be fluent with the multiplication table, but this is helpful. It's useful to kind of refer to check with all of the numbers that are shaded in blue on this particular chart are prime numbers. So these are numbers that have just just 2 factors, the number 1 and that number itself. So 67, for example, is prime. 97, for example, is prime. 73, 41, etc., etc. Let me check with 93. We did 93 earlier. 93 is not shaded in blue. So this means that 93 is composite. Okay, just checking our work quickly here. And then finally, you've seen a lot of these tips before. What is new here is number 3. So prime numbers have 2 factors, the number 1 and the number itself, and composite numbers have more than 2 factors. And always, always, always use division just to check, okay, just to make sure that a number has just 2 factors or more than 2 factors. I hope that this was useful, and I look forward to seeing you in 2021 with more math. So have a wonderful holiday, be well, and be safe.